Hello, I'm Maria Tomsalo from Cybernetica, and today I introduce you Pleak. Pleak is a web-based tool that allows to model and analyze business processes specified in privacy-enhanced business process model and notation. Pleak can be used in various ways to help design, understand, and analyze different processes and their connections. Using Pleak always starts with a BPMN model that can either be created in Pleak itself or imported if it is already existing. As a demo example, let's consider a process where a mobile device is sharing its location with some smart city service provider. At its very core, the main functionality is simply sending the location data to the service provider. We can model this as Pleak as shown here. Pleak's data disclosure table draws attention that in this process, the receiver and the parties in the network have access to this data. Then we see that the application server sees this data, it's visible, and it is shared over an unprotected message flow. Hence, while this process delivers the data, it fails to give it any protection. It is common to protect such exchanges with secure communication techniques, such as using TLS to communicate this data. In Pleak, we model this by annotating the message flow as a secure channel. The resulting process looks like this, and the analysis results can be seen in data disclosure table. The core change here is that the analysis indicates that the data is shared over a secure network channel. Hence, in this simple process, it is received only by the application server. In this process, we have extended the process of the mobile device side to let the device user decide which data is really sent. The user first decides if they are sending real or approximate data, and based on the choice, the right level of detail of data is written to the network message. The disclosure analysis of this process reflects only part of these privacy implications. We can see that the application server sees the location that is sent, and we can see that it sees something derived from the real location. However, the idea that some choice or filter has been applied is lost in this analysis output. Hence, in this case, it is reasonable to go deeper with Pleak analysis and use the BPMN leaks when analysis. For BPMN leaks when analysis, we have to specify the decision points and data processing in this process in our pseudocode. For example, the task share real data would simply copy all data from the real location to the location that is sent to the application provider. However, the share approximate data can be specified as filtering the input real location, for example, by writing this pseudocode here. After specifying all tasks in the pseudocode, we get the BPMN leaks when output. We have made the assumption that the real location data has three fields: classifier, coordinates, and user identifier. Our interest is which data is arriving to the application server. Therefore, we will take a look at the final data object called application data. At the first glance, it indicates that the user data is always leaking to the application server. However, the classifier is never leaked. The user choice is hidden behind the if in the table. In Pleak tool hovering over the if also reveals the condition. We can see that indeed the location is either leaked if user allows it, or only some data about the location that passes the approximation is leaked. It is not necessarily clear yet which alternative of the data sending is the right approach. However, so far we have seen how Pleak can be used to model and analyze the alternative sending processes. In practice, the sending probably depends on what the received data is used for and how. In order to analyze this more, in Pleak, the user should specify the process on the side of the application server and then analyze the variations of data sending in combination with the application process to decide which gives the security guarantees that are required. Thank you for watching the introduction to Pleak.